welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Welcome to CES! Are you excited to be in Las Vegas? Do you like my jacket? GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. That was real-time computer graphics. It would have been impossible without artificial intelligence. Everyone, today we're announcing our next generation, the RTX Blackwell family. Here it is, our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Well, now, with the Blackwell family, RTX 5070, 4090 performance at 549. And here's the whole family, starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. We managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. We're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate, using artificial intelligence, all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. What's really amazing is the family of GPUs we're going to put in here. The 5090 will fit into a laptop. You got a 5080, 5070 Ti, and 5070. One of the most important things that's happening in the world of enterprise is agentic AI. We've created 3 things for helping the ecosystem build agentic AI. NVIDIA NIMs, which are essentially AI microservices all packaged up. We optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or there might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the NVIDIA Llama Nemotron language foundation models. Well, the thing that we did was realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very fast response time, extremely small. They're what we call super, Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not. basically give feedback to other models. And so all of this is now available online. Well, these models are incredible. It's a number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. Today, we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. It is trained on 20 million hours of video, focuses on physical dynamic things. With this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based scenarios of the future. Because this model understands the physical world, it also could do, of course, captioning. And that captioning and the video could be used to train large language models. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. The magic happens when you connect Cosmos to Omniverse. Omniverse is a physics grounded, it's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers: the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world: Waymo and Zoox and Tesla, of course, in their data center, BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation AVs. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use NVIDIA to build self-driving trucks. 100 million cars built each year, 1 billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. Well, today we're announcing that our next generation computer for the car is called Thor. I have one right here. Hang on a second. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars. They're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. We think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. NVIDIA Isaac Group, this is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. So we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I just wish that DGX-1 was smaller. And, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. It's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And this is the chip that's inside. It is in production. This top secret chip is built for NVIDIA in collaboration with MediaTek and connected with chip-to-chip NVLink to the Blackwell GPU. This little thing here is in full production. We're expecting this computer to be available around May timeframe. This is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, anything, because it's a cloud platform. It's a cloud computing platform that sits on your desk, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Have a great CES, everybody. Happy New Year. Thank you.